Now in section 14.7, they've made a whole section out of actually not really any new information. We already know that if we have this written down, ln, that means, so natural log of x, that is log to the base e of x. E is the number that we met in the first half of the chapter. I won't go through that bit again. But there's just this special notation. ln stands for natural log, and that's kind of it, really, right? If you look at things like example 17 now, e to the power of x equals 5. Well, another way of writing that is natural log of 5 equals x, okay? So the base is the same as the base, the power goes over here, and the 5 goes over here. That's just through our definition of logs way of thinking about it. Another way of thinking about it is I do natural log of e to the x equals natural log of 5. Bring the x down, x natural log of e equals natural log of 5. Natural log of e is log to the base e of e, which is 1. So there's different ways of kind of getting there, but that thing means the same as x equals natural log of 5. And in the same sort of way, natural log x equals 3. That means the base to the power of 3 equals 5. Well, the base here is e, so e to the power of 3, base to the power of 3 equals x. And the base is e, so e to the power of 3 equals x. Okay, so there isn't any new information there other than sort of formally reminding you that this thing exists, okay? There is one thing that we do, which is they just throw in a little fact about logarithmic graphs, which is a bit irritating because there's a whole topic of logarithmic graphs. They just seem to want us to notice it, but there's not much detail here. I'm just going to remind you that y equals e to the power of x looks like that. Now I'm going to take a shortcut here, and I'm not going to discuss why this is the case very much. I'm just going to use a fact from, I think it's the second or third chapter of the second year Pure course, which is that if you have an inverse function, then the graph of it is a reflection in the line y equals x, okay? So this is the function. If I want to graph the inverse function, I reflect the function in the line y equals x. So that means that the logarithm graph is going to look like this, okay? Now, I know that's frustrating if you've not seen that fact yet, but trust me for the moment, because it's only going to be a couple of chapters into the next book where we'll be discussing why that's the case. If you're only doing the AS level, sooner or later on this channel I'm going to get the next book filmed, and you can flick forward and look at my videos on that if you're really interested as to the reasons why. This here is an asymptote, so that means this down here is going to be an asymptote, okay? And then this shoots off, so this is going to shoot off up here. So that's what y equals natural log of x looks like, and the reason is that natural log of x is the inverse function of e to the power of x. In example 18, I get equations like e to the power of 2x plus 3 equals 7. Well, if I take natural log of both sides, I get 2x plus 3 times natural log of e equals natural log of 7, and I've just applied the power rule here as well to maybe make it a bit clearer that the natural log of e cancels out. So 2x plus 3 equals natural log of 7, and I can solve the equation from there, okay? So I'm just using the techniques that we've seen before, only now the base is an e, right? There is nothing in example 18 which is new apart from, if you see ln, it means log base e, okay? So 2 natural log of x plus 1 equals 5. Well, that means that natural log of x equals 5. Take away this 1, divide by 2, which is going to give us natural log of x equals 2. And another way of writing that is this base to the power of this equals this. So e to the power of 2 equals x, and there's my answer. I suppose the reason it's different is because they're asking us for exact form, and we can do exact form as e to the power of something. But then if this wasn't a natural log, if this was a log base 10, we could have exact form here as well. You know, it would be 10 squared, and then we could work out what 10 squared is. So it really is just that, just this new fact that we've seen. Example 18, I'm not going to go over that one here, but suffice it to say it's the same as these questions. Example 15, which I did in the video on section 14.4. Okay, where are we? That's the end of that one. Just one section to go.